In the design of analog ICs, we are doing modeling. Under this bulk enhancement MOSFET, EKV small signal transconductance model. This model name EKV small signal transconductance model, mathematical model. So already in the last video we discussed about non-linear operating point, small signal increments only happen, what will happen, linear equivalent circuit, weak inversion in conduction, and saturation forward. Here in strong inversion, in weak inversion, sub-threshold GMG equal to ID equal to N by UTT, GMS IDF by UT, GMD, GM in gate, GM in source, GM in drain, IDR UT divided by UT, R for reverse, drain current reverse, return, forward, forward of drain current, under UT. Here drain current under NUT divided by NUT. This much of NUT, this much ID. This much UT, this much ID forward current, drain current in forward. Here this much in UT. Here this much of drain current return. Here in saturation mode, GMG, that is GM in gate, same here. In conduction and saturation, that is forward, same. Here different, ID different divided by UT in source. Here we have to multiply lambda with the ID multiply with the lambda. That's why this is the in drain, GM in conductance in drain. In strong inversion, here weak inversion, that is in the sub-threshold, happened in conduction and saturation forward. Here in strong inversion, in conduction, strong inversion in saturation forward. GMG equal to beta VDB minus VSP. VDB minus VSP. In VDB, VSP deduct, that is subtract from VDB and multiply with beta. GMS equal to two times N multiply with beta and ID forward. After multiplication, then we have to square root because scaling. And then here also same, but here reverse ID current in drain, in source forward current. But here we have to see, we have to look here, beta multiply with in gate, in source, in drain. Okay, here only drain current multiplying, here also with the n, 2 times n, and then after that square root for scale purpose. Here in get VDB minus VDB minus VSB, that much, then multiply with the beta, then only that one is the CMG. Okay, multiply VDB with the VSB. Okay, sorry, minus, subtract. Okay, then multiply with the beta only. Then how much is that? That is the here in gate GMG. In GMS, in source beta IDF forward. In drain reverse, actually here going, no, here flow forward like this. So here reverse only we are calculation, that's why reverse. Here forward, so that's why forward. Okay, then saturation in saturation forward, what is going on in a storm inversion. In GMG, where in gate, in gate, here, what is going on? This drain current multiplying this conductance only, no? Wow, what is going on mainly? Drain current going on, that's all. Then two times beta multiply with the ID for GMG in saturation mode, then divided by n, this much, it means physical meaning this much n, this much multiply, then square root, this is the GMG. Means this much, for this much n, this much we are finding, then that value is the GMG. Okay, 2 times beta ID. Okay, fine. In GMS, in source, what is going on? Here multiply, here divide, in gate divide, that is this much n, that is here multiply in source 2 times n, then beta, then ID, this ID current. Okay, what will happen in D, drain? What will happen in drain? Okay, GMD, here ID here only will start. So lambda multiplying with lambda equal to proportional to 1 by n. So direct ID. So this all due to conductance, ID must ID. Okay. Here only different because that gate no, here is different in conduction time. Saturation is different. Here same what we have seen before, last slide, that one same. Okay, GMS, GA, GMG, GMS, GMD, GM gate, GM in drain, GM in source, GM in gate, GM in drain, GM in source. Okay, equivalent circuit, linear equivalent circuit. Equivalence between models. Actually, this is non-linear operating. This is linear equivalent circuit. This one will happen small signal increments only. Okay, fine. Last. Here in equivalence between models, that is GM in gate, GM in gate. Here dou ID divided by dou VGS, dou VGS. VGS, dou VGS, it is called GMG. GMP equal to dou ID MP BS MB here with respect to, that is GMS, that is source GM minus gate GM minus drain GM. P equal P equal to air conductivity, air conductivity minus. That's all. And then here GDS, that is GMD in drain. What will happen here? Train current with respect to dou VDS in between here. This is okay. This is, that's all. Okay, that is called GMD and GDS. Then continuity between operating regions, continuity between operating regions. Here in x-axis log IC, in y-axis GMD GMG divide ID. Here log IC -4 -2 0 +2 +4. Here -4 to no, here didn't mention cycle. Here GMG divided by ID.